Hello mathematicians, puzzlers, and other curious people. In this video, we're talking about the three kinds of equations. So there are three kinds of equations, and it depends on what it takes for the equation to be true. One kind is an equation that is sometimes true, based on the variable having a specific value or one of a set of specific values, depending on the equation. So depending on the equation, there might be only one right answer, or there might be several right answers. And those are called open equations. You may also sometimes hear them referred to as conditional equations. You can also set up an equation so that it's never true, no matter what value you try for the variable. Those are called inconsistent equations because the two sides of the equation are inconsistent with each other. It's also possible to set up an equation so that it's always true, no matter what value you try for the variable, because the two sides of the equation are equivalent expressions, and those are called identities. So those are equations where the two sides really simplify to the same thing. So no matter what value you plug in for the variable, in that case, it'll just still automatically come out the same. So we've got three equations here. A little bit of spoilers, there's one of each. So let's see if we can figure out what this first one is. So 4 times x minus 7 is the same as the sum of 2x plus 5 and 2x plus 8. So let's see. I'm going to suppose for a minute that x equals 5. So let's see, 5 minus 7 would be negative 2. Negative 2 times 4 would be negative 8. I keep thinking that's a plus. It's a minus. You got to watch for those sign errors in your in copying. Okay, so now we've got 2x plus 5. So 10 plus 5 is 15. 2x plus 8, 10 plus 8 is 18. 15 and 18 is like 15 and 15 and 3, so 33. So here's something I notice. I notice that there is no way, since I got negative 8 in one and 33 in the other, there is no possible way that this is an identity. I know this is not an identity. Now, I don't yet know just from this whether this is an open equation or an inconsistent equation. I know that 5 is not a solution, but there are a whole lot of other numbers that I could try. So, for example, I could try 10. Let's see, 10 minus 7 is 3, times 4 is 12. And then let's see, 20 plus 5, so 25. 20 plus 8, 28. That's like 25 and 25 and 3, so 53. Okay, well, once again, no, doesn't work. So I know neither 5 nor 10 is the solution. Now, I could guess and check literally all day, and I might not get lucky if it's an open equation and guess the right thing. And if it's an inconsistent equation, I'll never be done guessing and checking because there's always another number I could try. So what we can do instead, when we think that it might either be an open or an inconsistent equation, is we can simplify both sides to find out which. So I'm not going to do anything that changes the value of either side. I'm just going to simplify each side. So I know I could use the distributive property here to say that this left-hand side is the same as 4x minus 28. Now I know I could use some addition properties, associative and commutative, and then combine like terms. Well, I could start with the associative property. So I'd have 2x plus 5 plus 2x plus 8 to just ditch the parentheses. And then technically I'd be using the commutative property to move this 2x up close to the other, I'm just going to skip ahead a little bit because I know once I combine those like terms, I'll have 4x plus 13. Now here's something I notice. I notice that 4x, no matter what I plug in for x, is always going to be, that term is the same on both sides. But then on the right-hand side, I'm adding 13 to it, and on the left-hand side, I'm taking away 28, so those cannot help but turn out different. So this is an inconsistent equation, again, because it cannot avoid turning out different. Now let's see. All right, if you are super observant, you might notice that I just fixed something off camera. So let's pick this back up where we were. So our next equation is 3a plus 6 divided by 1 plus 2 is said to come out the same as 3a plus the difference between 6 and 2a minus 4. Whew! That looks complicated. Well, let's try what we've been trying. Let's try 5 and 10. So let's see. 3 times 5 is 15. 15 plus 6 is 21. And then 1 plus 2 is 3, so 21 divided by 3 is 7. Now we also need to consider the right-hand side. So let's see. If we plug in 5, here we'll have 15. Let me just make a scratch mark there. Let's see. 6 minus, 2 times a would be 10. So we've got negative 4 and then negative 4. So 15 minus 4 is 11. 11 minus 4 is 7. Okay, from this, I know for sure that this is not an inconsistent equation because it has at least one solution, 5. I don't yet know whether it's an identity or an open equation. So that's still something I'm not sure about. Let's try 10 also. So let's see. 30 plus 6 is 36 divided by 3. 36 divided by 3 would be 12. And then let's see. 30. And then let's see. 20. So 6 minus 20 would be negative 14. And then minus 4. So 30 minus 14 would be 26. Wait, no. 30 minus 10 would be 20. 20 minus 4 would be 16. And then 16 minus 4 would be 12. So there are still a couple of options. One is it could be an identity. The other option is it could be an open equation where it just turns out that the two things we tried are both among the solution set. Now, we could keep trying things all day, but we might never find the one thing that's not in the solution set if it's that specific, or there might be many things that aren't in the solution set, but we might just coincidentally not try them. So the other way we can handle this, when we think it might be an identity or it might be an open equation, is we can simplify both sides. So let's take a look. If we've got 3 times a plus 6 divided by 1 plus 2. Well, one thing I know here is we keep saying, okay, well, 1 plus 2 is 3. We do that every time. Now, here's another thing I notice. I notice that both terms in the numerator are multiples of 3. So I can rewrite that numerator as a distributive property problem. And by doing that, I can say, okay, divide both the numerator and the denominator by 3 to get an equivalent fraction. So then I'd have a plus 2 divided by 1. Well, dividing by 1 doesn't change anything, so that's just a plus 2. Well, that seems easier. And we can see that it's consistent with our results. Like for 5, we got 7. For 10, we got 12. Now let's take a look at the right-hand side. So let's see, we've got 3a plus, I'm going to go ahead and pop off these parentheses here, so plus 6, and then minus 2a. Now remember, even though this property is specifically about addition, we can say, well, that's like plus negative 2a. So we can go ahead and write that anyway, and then minus 4. Now we can say, okay, well, we could get those terms together, sort them out. Technically, we're using the commutative property of addition. So we can group up our a terms and our constant terms, being careful to keep the pluses and minuses with the term that they're in front of. So the 3a is still positive, and that's the implied positive since it's first. This minus 2a keeps its minus with it, the 6 keeps its plus with it, and the minus 4 stays minus 4. Now let's see, 3a minus 2a, well, that's just a. 6 minus 4, well, that's just 2. Oh, so these are always going to be equal. No matter what we plug in, if we are in effect only increasing both of them by 2, it's got to come out the same. So this is an identity. Now, based on spoilers, you probably expect that this next one will be open, and here's how we can check that. So I'll work over here. So we've got 3 times n plus 2 minus 4 is supposed to come out the same as 12. One thing that often happens with open equations is they might only have the variable on one side, or if they don't, there would be a way you could get the variable on just one side. So if we start by distributing this 3, then we'd have 3n plus 2 minus 4 comes out to the same as 12. Well, then we could simplify this. So plus 2 and then minus 4 is overall minus 2. Now, I'm not going to take this to completion by completely figuring out this equation. Feel free to on your own time. But we can see that there could be a specific number that we could plug in here, but not just any number would do, because whatever number we try to plug in, we'll multiply it by 3 and then subtract 2, and that's supposed to specifically come out to 12. So you can see how that would change depending on what number we plugged in, so that's why this is an open equation. I do believe there's an answer to it, but the answer would take a little more work to find than we're going to put in this particular video. That's the 3 kinds of equations: identities, open equations, and inconsistent equations, and how we can identify them. So I'll say for now, calculator.